line segments IN, this is segment IN over here, and TO, this is TO here, are reflected over the line y is equal to negative x minus 2. So this is the line that they're reflected about, this dashed purple line. And it is indeed y equals negative x minus 2. This right over here is in slope-intercept form. The slope should be negative 1, and we see that the slope of this purple line is indeed negative 1. If x changes by a certain amount, y changes by the negative of that. If x changes by 1, y changes by negative 1 to get back to that line. If x changes by positive 2, y changes by negative 2 to get back to another point on that line. And the y-intercept, we see when x is equal to 0, y should be negative 2. When x is equal to 0, y is indeed negative 2. So we validated that. Now they say draw the image of this reflection using the interactive graph. All right, so we can move these lines around, and we want to reflect these. And I could try to eyeball it, maybe it's something like this. I don't know, this doesn't seem exactly right. That looks close to the reflection of IN. And for TO, I'd want to move this down here. TO looks like it would be, I don't know, I'm eyeballing it. This is close, but I can't be close. I want to get exact. So I've copied and pasted the original problem on my scratch pad so we can find the exact points, and so I don't just have to estimate this. So let's go to the scratch pad. So exactly what we just saw. And the main realization is if we want to reflect a given point, say point I right over here, what we want to do is we want to drop a perpendicular. We want to find a line that's perpendicular, a line that has the point I on it, and it's perpendicular to this line right over here. Remember, this is the line. Let me do this in that purple color. This is the line y is equal to negative x minus 2. Its slope is equal to negative 1. So I want a line that goes through point I, that is perpendicular to this line, and I want to drop it. I want to drop it to the line that I'm going to reflect on, and then I want to go the same distance onto the other side to find the corresponding point in the image. So how do I do that? Well, if this purple line has a slope of negative 1, a line that is perpendicular to it, so this thing that I'm drawing in purple right over here, its slope is going to be the negative reciprocal of this. So the reciprocal of negative 1 is still just negative 1. 1 over negative 1 is still negative 1, but we want the negative of that. So the slope here needs to be 1. And luckily, that's how I drew it. The slope here needs to be equal to 1, which is however much I change in the x direction, I change in the y direction. We see that. To go from this point to this point right over here, we decrease y by 4, and we decrease x by 4. Now, if we want to stay on this line to find the reflection, we just do the same thing. We could decrease x by 4, so we'll go from negative 2 to negative 6, and decrease y by 4, and we end up at this point right over here. So we end up at the point, this is x equals negative 6, y is equal to negative 4. So this point corresponds to this point right over there. Now let's do the same thing. Let's do the same thing for point N. For point N, we already know if we drop a perpendicular, if this is perpendicular, it's going to have a slope of 1, because this purple line has a slope of negative 1. And the negative reciprocal of negative 1 is positive 1. And let's see, to go from this point to this point of intersection, we have to go down 1.5. We're going down 1.5, and we're going to the left 1.5. So we want to do that on the other side. We want to stay on this perpendicular line, so we want to go left 1.5 and down 1.5. And we get to this point right over here, which is the point x equals 3, y is equal to negative 8. And so we are now equidistant. We're on this perpendicular line still, but we're equidistant on the other side. So the image of IN is going to go through negative 6, negative 4, and 3, negative 8. So let me draw that. So let me see if I can remember. Negative 6, negative 4, 3, negative 8. So I have a bad memory. So negative 6, negative 4, and 3, negative 8. And I was close when I estimated, but I wasn't exactly right. So that's looking pretty good. And then actually we can do the exact same thing with points T and point O. And let me do that. So point T, to get from point T to the line in the shortest distance, once again we drop a perpendicular. This line is going to have a slope of 1 because it's perpendicular to the line that has a slope of negative 1. And so to get there, we had to decrease our x by, decrease our x. We're going from x equals 5 to x equals, looks like half. So x went down by 4.5 in the x direction, and y also needs to go down by 4.5. So if we want to stay on that line, let's decrease our x by 4.5. So that's half, 1, 2, 3, 4. And y needs to go down by 4.5. So that's half, 1, 2, 3, 4. And we get to this point right over here, which is the point x equals -4, y is equal to -7. So -4 comma -7. So this should be at x equals -4, y equals -7. And there's a couple of things you could do here. You could just say, hey, this is too long. This is, or 2 units long, not like too long in length somehow. This is 2 units long, so maybe this is 2 units long. So this is feeling good, pretty good. But let's just go through the exercise for point O as well. So point O, once again, this is going to have, if we drop a perpendicular, it's going to have a slope of 1. So whatever our change in x between this point and this point, we're going to have the same change in y. And our change in x to go from 7 to 1.5, our change in x is 5.5. So let me do it this way. So the change in x here, so change in x is equal to -5.5, 5.5. If you subtract 5.5 from 7, you get to 1.5. And our change in y is also -5.5. Change in y is negative, you're not going to see that, so I'm going to do it different, -5.5. And so we need to stay on this line. So we want to change by those same amounts onto the other side of that line. So if we decrease our x by 5.5, so half, 1, 2, 3, 4, 5, we get there. And y by 5.5, half, 1, 2, 3, 4, 5. We get to the point x equals -4, y is equal to -9. So we get to the point x equals -4, y is equal to -9, and we're done. We have figured out the reflection of these two segments.